Hello, everyone. I'm actually going to talk about Orion, and you will know very soon what it is, what is the vision for what we are doing with Orion, the benchmarks, and the future outlook for it. Basically, Orion is an open source framework for doing CKML or validity ML. And we open source this framework for the community so they can create their own verifiable models, so they can create a new set of new applications for the blockchain, like new primitives for DeFi, like yield, enhancement strategies, risk assessment, etc. We have a whole ecosystem around Orion. We have the framework itself, that is the open source tooling. We have the hub, that is the collections of tutorials and things that the community makes. The academy, that is how you can start learning. Orion, the tutorials, how to build your own neural network, how to start integrating it into your protocol, etc. Then we have the toolbox, that is, okay, given this framework, how can I easily integrate it into my other tooling? So we have there some tools that can help you out. And this framework is built in Cairo, that is this verifiable programming language that is made by Starware. And we build all the primitives so people can build the right functionalities, like if you know something about ML and PyTorch, we have a very similar API where you can have the same developer experience for building these primitives. For example, we provide tensors built in, so anyone can build tensors the same way they can do it in Rust and with PyTorch. We also have all the primitives already built for neural networks. So you can have all these linear layers, convolutional layers, ReLU activation, softmax, all these operations that are very well used in the ML community to create these models. You can also have it, you can build it, and create your own model. But it's not all about neural networks and tensors. We also support machine learning algorithms, like we support XGBoost, decision trees, random forest, and you can just bring your model that is trained and convert it into Orion, and basically you can have the same functionality, but in a verifiable way, so you can use it whenever you want. Aside of Orion, that is basically focused on the inference side of the pipeline for machine learning, we also have the right tooling for building these solutions. So you don't need to build in Cairo if you don't want to. So instead of that, you can just code your Python code, use PyTorch, TensorFlow, your Fabric framework. You can build your model. You can train it on your data. You can build your solution. And once you have your model saved, you can use the CLI that we built to convert this model directly into the Cairo representation. And once you have this Cairo representation, you can execute your verifiable model. You can generate the synchronous proofs, and you can verify them on chain, and you do whatever you want to do. Aside of that, we also manage all the end-to-end lifecycle of models, so it's not just about generating proofs and verifications and transpiling models, but it's also about solution and scaling, so you can very soon will be able to deploy these models as well as a service to create inferences. And very recently, we started working on what we called cost of Orion. That is, okay, what is the actual results and benchmarks for executing these models and the proof generation time, what is the cost, and what is the gas usage. And for these benchmarks, we use the Lambda class prover that is called Platinum prover. We use it as the baseline for generating these results and these benchmarks. And what with these benchmarks we try to make is we create a depth benchmark where we basically assess with different depths for simple neural network what is the cost of generating these proofs and verifying them using Cairo. But there is some disclaimers to take from all this benchmarking. The first one is that the prover is not optimized for performance yet. It's like the initial version that they released. There is no enhancement, so it's more focused on stability at the moment. It's only using CPU. There is no GPU acceleration or anything like that. As well, the programs that we generate, the Cairo programs, are not parallel executions, at least for now. So it's everything single-threaded and single-core, and just to take in mind. So you can see, like, we can, in this benchmark that we did, till 50 layers of neural networks, that is the same size of a typical computer vision model, that, like ResNet 50. We can execute and prove the inference in like 20 minutes and verify in 10 using this initial Platinum prover implementation, but it's getting better day by day. So what are we working on in order to improve all this performance? We have two sides. One is the prover side, and the other one is more focused on the execution itself and the framework. And we have basically 4 main things that we're implementing in terms to improve the performance. One is MLIR. We are working also together with Lambda class in this framework that is Cairo to MLIR. So we can execute the Cairo inference directly in MLIR. So there is like no performance downgrade. It's like you can use CPU, you can use CPU, you can use whatever you want. It's highly parallel, and asynchronously, we can generate the knowledge proof associated with that. So it's not like synchronous, not anymore, and you can have the best of both worlds. Also, there are like prover improvements, like Lambda class is creating an amazing prover, and by the end of the year, it's expected that the performance is like a 10x improvement. So like very good prospect in that side. Also, we are looking into pipeline parallelization, and it's like how, without changing anything in the prover, we can optimize the execution so it's faster. And in this way, we are like applying different techniques like pruning or PyP, that is how to parallelize the execution of the multiple layers of the neural network with just setting different workloads for activations during the inference. So basically, we are splitting by layers the execution, and you can execute these layers in parallel, so the execution itself is faster. So it's like some kind of recursion-like for the execution of the inferences. And then is the Cairo compiler, where, as you probably know, there is the Cairo BN that is like more focused for the blockchain, but we are working in the compiler to integrate also new built-ins, so are not like blockchain focused and are like more for ML, so we don't need to execute in a naive way the executions depending on these blockchain-based operations, so we can have these built-ins specifically built for ML. As you saw on all these previous slides, Orion is very related to Cairo, but we don't want this to continue the same. So we want to expand how people build verifiable machine learning. And right now, like, you have all these Python libraries like scikit-learn, like PyTorch, Hugging Face, and on the other side, you have all the CK DSLs like Cairo, Circom, Halo 2, etc. But there is no way to mix them together, like in an easy way. So that's why we are building Orion, so we can bring all these different libraries into multiple CK backends, so people can use the solution as they want and use the backend that they want for the solution. So for that, like very soon, like by the end of the year, we're going to expand the Orion ecosystem into more CK frameworks to not only Cairo, but also Noir, RISC-0, and ECKL. And you can interact with all these multiple backends for the Orion ecosystem using the CLI if you don't want to write any kind of model in these frameworks, and you can just build your model in Python and that's it. You can convert it into any of these multiple backends, or you can build your own model using our Python SDK that is going to be released soon. So you can build the models instead of using the CK DSLs. You can use Python, and you can create your whole workflow for creating these actions on chain for models. And that's everything. Thank you very much.